bit revision on what I did this morning with a PGSS student. This is our picture this morning, and then it's like some sort of revision. I will do that. For just bear in me for those who already there this morning, and then I will continue with the second part, which is a small part on research contribution. Okay, research student productivity versus research contribution. So my layout will be a research degree, research subject productivity, and research contribution. What I will do is I will go through the slide very fast and just focus with the second part of it, and then just focus on the second part of the slide. Okay, but I will continue with sharing the first part very fast. Okay, what is research degree? I'm referring to PhD and MPhil, and then there must be a reason why students want to continue their degree, because they want to know research knowledge, they want to become expert, they want to practice, okay, they want to engage with the peer, and then to boost their career, especially in academia life. Also, not to forget about networking. Okay, in our school, software engineering are both field that we have both a field in software engineering in MPhil and PhD program. So those who want to pursue a software engineering research field, we offer both in MPhil and PhD program. Okay, so what I color here, this is maximum registration, which are 16 semester for PhD student. I color a green, meaning that the student in 5th semester can submit a thesis, and then I color, it's supposed to be I color a 6th semester for them to graduate normally. So 5th is early graduation. So for MPhil, as early as semester 3, they can submit their thesis. And then normal submission is semester 4. When we're talking about thesis, there are two types of thesis, conventional thesis and by publication thesis. On the, I'm not sure the date, I think next month, 21st November, we invited SPS and Prof Zain, our former Deputy Vice Chancellor on academics and international. We'll talk about how to write, how to supervise, and how to write thesis by publication. Okay, we will invite all students and lecturer to join the talk. All right, so you when we're talking about productivity, we might want to achieve something. So students must aware on what are the publication requirements before they can submit the thesis. In UTM, students who have intake before this semester have different requirements to submit thesis as compared to students who register this semester. Okay, the type of journal they need to publish are a bit different from their senior student. And then thesis by publication also need to have its own requirement for publication. I'm not going to detail it up. Okay, when I go to research student productivity, when we're talking about productivity, if we're talking about productivity, we want to achieve certain goals. So in this case, we want to achieve, we want to get PhD degree and MPhil degree. Okay, in order to achieve the goal, we need to plan and we need to act in order to success with the goal that we set. So habit is the things that I would like to emphasize. In order to get things done productively, we need to change our habit. By habit must have an integration of knowledge, skill, and you know what you want in your PhD and MPhil. If you don't know what you want, what is your vision, you don't really know how to change your habit. So when we're talking about productivity, we're talking about maximum result or output with less time. Get more things to done with less time. Okay, So in this case, we want to have as much as quality quality research output and minimum semester and minimum cost. All right. So when we're talking about research output, there are many types of research output, but the minimum requirement of UTM students are thesis, paper, book chapters, and conference for MPhil student. Okay, and you cannot run away from methodology, technique, code, or program for those who are doing so. And you also need to do case study or data set for some of the students. But the rest are optional. And then when we're talking about productivity, the main thing, the first thing will come to our mind is gradient on time. So gradient on time, why we call gradient on time productivity? Because you can manage to complete within minimum time. Okay, so gradient on time for PhD student is 42 months till 48 months. Okay, and then 24 months for MPhil student. Okay, it's not easy to get gradient time, but it's not impossible. It's possible to plan. Okay, when we're talking about gradient on time, it's about time and cost. We want to minimize time and cost. It's not an easy task to plan for gradient time, but it's not too late to plan, especially for those PhD student in semester 1 to 4 or semester 1 to 2 for MPhil student. The rest you still can plan, but you plan to get more with less time that you have. Okay, so here I would like to share how to plan. When you plan, you need to look at the output and expected standard. When we look at expected standard, we need to look at the university standard, your supervisor standard, other PhD thesis standard, and the examiner standard. Okay, the phase of research project that I discuss here is from FIN 2005, where we will go through phase by phase what are the things that you need to plan in each phases. So the start and end, you choose the time. How many semester you want to complete your task? Is it for master student you want to complete in 3 semester, in 4 semester, 5 semester, 6 semester? Or for PhD student, you want to do it within 6 semester or 7 semester? That's what we call estimated time. Okay, so the first is initiation. Initiation is where supervisor, you engage with your supervisor, you choose your subject, project, and then you register courses and enroll your courses. And then each supervisor and student must know their responsibility. Okay, and plan, when you plan, is very important for your first assessment. Okay, first assessment is the plan for your MPhil or PhD. So it's very important to know that semester 3 is a compulsory first assessment for PhD student, and semester 2 is compulsory first assessment for MPhil, but you can do the first assessment before that. Okay, and then there will be grade given to you for your first assessment. And one more thing I would like to emphasize here, in first assessment, you can do your MPhil conversion to PhD. Okay, if you want to convert from MPhil to PhD, you will need to do it during first assessment. Okay, there are different requirements. The third phase of research projects is execution, where you need to get your result. You need to execute. There are 2 types of execution tasks. The first one is preparatory tasks, where you need to do literature review, justification, all the initial result. Basically, that one is what you have in your research proposal. And then the second task is main task, where you want to achieve your objective. Usually when we're talking about tasks, we connect it with, we related it with publication. And you need to plan what you want to publish. Definitely, you need to plan for your thesis, you need to plan for your journal, you need to plan for your conference paper. How to plan, the number of it, when you want to do it. The best is to sit with your supervisor to know when what result you want to publish, where you want to publish a particular result. Okay, so so basically you will do your publication once you start with your task execution. So is it really necessary to publish? Yes, in context of UTM, because publication requirement is part of the requirement to allow you, to enable you to submit thesis. Okay, but there will be more publication required, more quality publication required if you want to publish by thesis by publication. But if not, you can still wait certain of your a number of publication after you complete your thesis. But and again, there will be a minimum requirement of publication you need to fulfill before you can submit thesis. Another important thing is monitoring and control. This one need to be done by individual student, but with the help of supervisor will be very helpful in controlling and monitoring. This is part of the task of the supervisor as well, to monitor and control the student progress and tasks. Okay, because when we talk about research, it's about repetition and finding something. It's things that we do repeatedly. If we do something repeatedly, we need to really monitor when we need to repeat, when we need to end the process. Okay, this is a linear expression of research. Actually, research is not linear. Okay, I show you one example of the way we can monitor and control work, where after you complete the first objective, you need to decide whether you need to redo the objective or not. If you need to redo, then you need to do the research part. But if you complete or satisfied with the first objective or problem, then you can go to the next objective. Okay. The last one is completion. Completion, if you ask me, the toughest part of doing research is the planning and the completion. The task execution is thing that quite enjoyable because you already know what you want to do, just that you need time to do the task. And that, if you ask me my opinion. Okay, if you do task thesis submission, it's not a simple process. Okay, you need to start with notice penghantaran thesis or thesis notice submission. Okay, where your supervisor will work with you in order to appoint the examiner. Okay, you need to plan properly when you need to do this. Not too long, but minimally at least 3 months before you submit your thesis. You need to plan properly. And then another things that I would like to issue here is thesis submission. I received an email from my from one student last week saying that the deadline for last semester submission was 31st September, right? And then he or she submitted her or his thesis to school, and she don't know that she need to submit the thesis to faculty in order before 31st September. They thought that if they submit to school before 31st September, meaning that they already fulfilled the requirement of thesis submission. But unfortunately, the deadline actually 31st September is for faculty to receive the thesis. So what happened was, faculty rejected to accept the thesis earlier, meaning that the student missed the deadline and he or she need to register this semester and submit the thesis. So beware of the process of thesis submission. Okay, I'm not going to go through this. There will be many tips for you to write thesis. Okay, and then before you submit, make sure you fulfill the checklist. And then there are also many tips for you during a PhD session. I just want to discuss about this. Before Viva, examiner will read your thesis and then will mark what is your result, initial result. And then during thesis, if there are any conflict, the Viva chair session are responsible to coordinate the result with the examiners. And then after you get your correction, you need to do correction and make sure you fulfill the correction given by the examiner. Okay, that is the process. When you know the process, in order to make sure that you are productive, you need to plan. Okay, regardless of where are you in the middle of your PhD, are you at the beginning of your PhD or in field, or are you at the end, you still need to plan all the phases, meaning that if you are already presented your proposal, then you need to plan your tasks and you need to plan your completion and things like that. You still need to plan until you complete your PhD. Okay, that's why I said this activity is learn from the past, live in the present, and plan for the future. Okay, so I gave few example of planning. Okay, this is the one that I would like to focus with our group today, about research contribution. How to end? How do we know how to know whether the research contribution is complete or not complete, or enough or not enough? Okay, I really like this phrase is done is better than perfect, because there will be no perfect works in PhD. Why? Because PhD and field is, we call it research. Things not going to be complete if we put the name as research. Everything can be do and can be redone and can be redo differently and can be search something new within the area. So nothing perfect in research, because we call it research. We keep on continue improving and search for a new thing. Okay, so that's what I want to discuss in the second part of my presentation today. Okay, before I start, I would like to differentiate what's the difference between MPhil and PhD, so that we know what's the difference between both contribution. Okay, when you're talking about contribution, MPhil is, we expect the student to gain full-fledged knowledge on the subject, meaning that in our case is software engineering subject, and also provide proper knowledge for further research, meaning that what you do in your master is some sort like step towards further research, meaning that after you complete your MPhil, you get an idea actually how to really extend that work to become a PhD work. That is the purpose of MPhil. Okay, and PhD is adding something new into the existing knowledge. In our case, is software engineering or computing body of knowledge. Okay, that's the main difference. When we're talking about productivity, we need to know what we want to, what output or contribution is expected in order to allow us to make sure we achieve the knowledge or the contribution, so that we can become more productive. And then MPhil, we have the different duration. For MPhil 2 to 4 years, PhD 3 to 8 years. So for MPhil student, if you do your MPhil 3 years, I think it's too long, because you can do it MPhil 3 years. It's some sort like too long, because you can complete your PhD in 3 years, but not everybody can. And again, we can say not everybody can complete their PhD in 3 years. When we're talking about MPhil assessment and PhD assessment, they are the same, just that the knowledge that they contribute, this the publication that they need to do are different. Okay, so we have minimum different publication for MPhil student, and then minimum publication for PhD student. Okay. Oh, I forget. The one that I listed here is the one with before semester 1 and after semester 1. Yeah, there's a few difference. Okay. Main computing discipline. When we're talking about contribution, definitely we are looking at the contribution from computing or software engineering body of knowledge. Okay, we need to know the discipline before we can contribute in the discipline. And then we need to know the type of discipline that we want to contribute. Okay. When we're talking about computing, we have the theory which support the computing theory, like theory of computer science, the empirical theory behind it, and things like that. And then we have the development point of view, where how we want to apply it, how we want to develop it, so the application part of it. So from the range of left-hand side and right-hand side, from the theory part, we're going towards the implementation and development part, deployment part. X and Y axis, we're looking at the type of products or target that we want to do, we want to contribute. Because when we're talking about computing, we're talking about hardware as well, because computer engineering is part of computing. Okay, so when we're talking about computer engineering, okay, and then we're talking about software as well, and we're talking about application of the technology in solving problem, and we're talking about the organization issue when we want to introduce computing in solving the problem. Okay, so it's referring to different discipline. Okay, when we're talking about computer engineering, we focus with computer hardware, architecture of the hardware, and software system infrastructure. Very much down here, from the theory of it, of the things, until the application. Okay, when you're talking about computer science, less development, but it doesn't mean that no coding. You still need to develop, you still need to implement, but the development that you do is as a test bed, as a test cases for you in order to verify the theory and algorithm that you propose. Okay, that is computer science. When you're thinking about information system, very much at organizational level, you want to know how an organization can accept any computing technology that we introduce. Okay, when we're talking about IT, it's more on application. Okay, more on application of the technology and how it can be implemented into the organizational system. Okay, that is from as computing curriculum structure. Okay, but when we're talking about software engineering, it is in the middle. If you're talking about software engineering, we can contribute in all most part of the spectrum, most part, but not all, not in detail in hardware. We can also start in hardware. For example, some of our software engineering students doing embedded system, they also will consider on the hardware part of the embedded system. Okay, and then we also will look into the organizational part, but not as detailed as information information system student will look into the organization part. Okay, but our major business is software development, the discipline of software development. How software engineer, what is the best discipline that we can introduce or we can propose in order to improve software engineering body of knowledge. Okay, that is what we want to contribute. When we're talking about software engineering, any engineering, regardless whether we're talking about software engineering, electrical engineering, whatever engineering, definitely is about implementing the knowledge in practice. Okay, engineer is taking the theory, using the theory in practical life, like in engineering life. Okay, like for example, electrical engineer will use physics theory in electrical engineering development. Chemical engineering will use chemistry science, okay, in the implementation of chemical engineering. The same thing with software engineering. We will use the theory behind computer science and theory in computer science in our practice and try to to help software engineer to practice the knowledge. So in this paper, we talk about the difference, the quadrants of when we're talking about practical relevance and academic relevance. Because when you write your contribution in your thesis or in your paper, usually we write it from 2 points of view, which are from academic point of view, what are our contribution in terms of academic point of view, usually body of knowledge point of view, and what are the contribution that we made in the practical point of view or from the software engineer point of view. Okay, so this paper highlighted there are 4 quadrants. The best one that we want to achieve is both upper right, which is highest value both world, meaning that practice, very practical and with support of academic knowledge. Okay, but that is not an easy task to do. You need to validate your work toward the practical point of view, and also you need to validate your work from the point of view of academic. Okay, and you can also have, okay, in quadrant 2, where it's more practical, less academic. Okay, usually research institute in any organization, like research institute in Microsoft, research institute in any organization, they are more focused with the practicality of the research result. Okay, and most, not all, most of students in university, they're focused with Q1 quadrant, which is majority of our works is more on theory and minimum in practice. But as a software engineering, if we're doing a PhD and MPhil and software engineering, you cannot ignore the practical point of view. You still need to mention or link your research result to practical point of view. Else, we just like any computer science student, which only apply without looking into how actually software engineer will use the theory or the model that we propose in their practical discipline. Okay, so don't focus with quadrant 3. Quadrant 3 is low in practical, low in academics. Definitely no thesis can be and no contribution can be made at that quadrant. So if mostly for quadrant 2 and quadrant 4, we used to have PhD industry or MPhil industry, where we have supervisor from university, and we also have supervisor from industry. Okay, this is the mode of research, PhD industry or MPhil industry. So both supervisor from industry and academic will work together to make sure the student can make contribution in Q4. Okay, so as I mentioned just now, Q3 is usually you doing contribution with industry and less with academic. So if you are doing it with only academic, so most probably you will go into Q1 quadrant. But some of the researcher, research we execute in university also have collaboration with industry. If that is the case, we also can manage to get Q4 for some of the not Q4 publication, Q4 quadrant in PhD or MPhil. This is what Dr. Razia already discussed in her presentation. I'm not sure whether you still remember. I'm going to repeat it. When we're talking about practice, we're talking about real world and practical problem. And then the solution must be practical to the world. Okay, you must use it in the real world solution, and you must try it in the real world solution. So this is real world. If we want to have quadrant 2 and quadrant 4 contribution just now, we must focus here in this phase of the contribution. Okay. And then we in the university, we try to repeat the problem. Okay, when we do the review, we will look at the literature review, we look at what industry problem, what their problem that they face, and we try to idealize the problem and put it in a research problem. Okay, where we in academic life and academia can repeat and can do research with that problem that we have. So actually what we have in academia life problem is more idealized as compared to the real problem faced by industry, because there will be more parameter that we need to consider in a practical problem. Okay, so set a researchable problem. So meaning that from the industry, that's the different from what we have in software engineering as compared to computer science. Because computer science, they're not going to look into in detail the practical problem. But as a software engineer, because we are trying to provide theory for software engineer, we really need to really look in detail what are the practical problems and how we're going to analyze and how we're going to design a researchable problem that we can solve in academia setting. And then we have research product, okay, and we need to go through in our evaluation is once we have a solution, we will have the idealized solution, meaning that the solution cannot be directly go to practical. Okay, so meaning that we need to have two phases of validation. Either we only idealize, say that we solve the idealized problem, and then we conclude our thesis. That will be the Q quadrants 3, as we mentioned in previous quadrant 2, quadrant 4, quadrant 3. That will be the contribution. Very heavy with academia for contribution if you do validation task 1. If you do validation task 1 and at the same time you're doing validation task 2, you will contribute in quadrant 4, as I mentioned just now. Okay, but if you only do your validation with task 2 without task 1, you will achieve the quadrant 2 contribution, as I mentioned just now. So if you ask me, is it enough for PhD? Yeah, it's enough. If you only focus with certain quadrant, definitely if you only focus with Q3, it's not enough. Okay, if you do Q1, quadrant 1, quadrant 4, and quadrant 2, it will be enough, but very much depending on what contribution you want to highlight. Okay, but majority of us doing quadrant 1, but there are some students who manage to do quadrant 4 as well. Okay, like any student which work with industry, which really practice in industry, they can achieve up to quadrant 4. Practical, when we say how to design that type of research is, first we need to choose the research topic. When we need to decide at the beginning of our research whether we want to go into industrial relevant research or working on academic topic research. Hot academic, because in academic we have a bubble of technology that will be pop up, then we will marriage the bubble together with software engineering problem. Like for example, now the big bubbles coming out like data science, blockchains, and so this academically hot topic can be integrate in software engineering problem solution. Okay, so that's what we call working with academically hot topic. Look at what is the hot topic and try in software engineering and look at the bubble from the technology that we want to experiment and research with software engineering problem. Then that is one decision. Or you want to go directly to industry, you need to identify the problem in industry and focus with practical relevant research. Okay. So the impacts are different. If you focus with academia, the impact will be with a publication, with citation, because you are doing something new. Industry have not tried yet. So everybody want to have a look at your paper, just to have a look the possibility of implementing it in the industry. But if you're doing practical, what's so good about practical, it can be used directly. The technology can be transferred directly to industry, both making contribution, meaning that if you're doing practical relevant research, industry will get benefit. But if you're doing academic, you explore something new, inshallah, industry will get benefit later once the technology are ready, once the hot topic can be implemented in the practical problem solving later. Okay, because in academia, what we do now can be implemented like a few years after further research can be done to move that research from giving academic impact, move it to technology transfer impact. So when we talking about research, I try to link productivity of the research and contribution. Okay, we need to have environment in order to become productive. Okay, so research opportunity is one of the environment. A research opportunity, whether in industry or in academia, contribution is an environment. Which one that you want to tackle? Okay. And then research motivation, the researcher motivation, the supervisor motivation is behavioral. Okay. And in order to organize research, in order to conduct tasks, to perform tasks in research, we need to have research competency. We need to identify what skill that we require in order to complete the research. You need to discuss with your supervisor. What are the skills that you require? If you require certain skill, your supervisor and you must choose the proper training so that you can get the skill and complete your research. Else you cannot complete your research without proper skill set. And then academic knowledge creation process, meaning that we need to manage the knowledge, manage the process in order to make sure that we are productive in research. Okay, we need to somehow manage. And then when we productive, we can make contribution. Okay, so I think that's all for me today. The main topic about productivity and research phases just now, I extracted from this book. Okay, thank you very much. That's all. Luqman, back to you.
Okay, thank you, Dayang, for the sharing. Now, as usual, we will open the Q&A session. If anyone has any question or comment regarding the topic shared just now. There's a question from me, Prof. Just want to ask. So if about the GOT, so if I want GOT, I need to complete also the corrections, not just the Viva in the 6th semester.
In the 7th semester.
Oh, 7.
Kalau 6, 36, dia 42, Luqman, in the 7th semester. Meaning that you need to submit in 6th semester. You need to complete everything in the 7th semester.
Meaning that complete correction.
Complete correction, complete Senate later as well. After you complete the correction, you need to go do hard binding, right? After you do hard binding, then we in academic affairs will submit the graduation application to Senate. So complete up to Senate issue the letter must be within 42 months for Myra and 48 months for Mohe.
So in the 7th semester, you need to complete that.
Yeah, 7 semester. Submit everything. So the best situation is usually we require at least one semester. If you submit early in semester 6, you can complete most probably in semester 6. But normally student will submit at the end of that semester 6, right? Then semester 7 will be the process of viva, the process of correction and everything. At least 6 months or 5 to 6 months. So you need one semester for completion phase. Kan I mentioned about completion phase in my graph just now. Okay.
And it depends on the viva grade.
Yeah, if you get B1, then it's only like 3 months for PhD and 1 month for MPhil. So you can like easily can complete it within like 2 to 4 months to get the Senate letter. But if you get B2, 3 months for MPhil and 6 months for PhD. But you can submit earlier, even though they said your correction is maximum 6 months. After first or second months, you can submit the correction, provided your correction fulfill the list given by examiner. The thing that I usually say to my student, make sure, because if you want to submit early the correction and suddenly the examiner rejected the correction, it take longer time for you to come back to you and redo the correction. It's the best is for you to really go through the examiner comment, and if you having any problem to understand the examiner comment, you can directly communicate with examiner, because during correction you can communicate with examiner, okay, but not before viva. You cannot communicate with examiner before viva.
Okay, understood. Thank you, bro.
Welcome.
Assalamualaikum, Dayang.
Waalaikumsalam, Adham.
Only one question, not a question, just to know your opinion. Okay, is there any specific guide or procedure, okay, if the students coming from industry, okay, and then the problem of the PhD is coming from the industry, okay, and then the co-supervisor appointed by the industry, the co-supervisor lah. Is there any specific guide or rules in terms of publication, in terms of contribution, and so on?
Okay,
because
PhD,
thank you.
You're talking about PhD industry, like Adham.
Okay.
I need to find. Okay, before this, okay, the requirement of PhD industry is the students must from industry. That is first one. During the PhD period, he or she must be in industry, meaning that she or he is still working. Like we supervised Dayudin last time, right? Dayudin actually eligible to have that PhD industry, but PhD industry, the fee is a bit higher, because the student stay put in industry, the supervisor will go to industry, visit the student. That's the reason why the fee is higher. Okay, and then the contribution can be focused with quadrants, quadrant 2, as I mentioned just now, quadrant 2 and quadrant 4. So it can be less on quadrant 2, quadrant 3. Okay, so we have a guideline on PhD industry. Okay, but before this, Malaysian government provide quite a number of grants for PhD industry, but lately we don't have any not that many grants for that. That's the reason why PhD industry is no longer no longer popular. But I think we already complete all our PhD industry viva that we have before. We already have our last PhD viva, PhD industry viva last year. Okay, and then beside having more supervisor, at least one from industry and one from academia, during the viva, we also need to find more examiner for PhD industry, which is one from industry and one from three examiner, one internal, one external, and one from industry, 3 examiners. Okay, there is a guideline. If you want, I can find and share with you, Dr. Adham.
Okay, thank you for Dayang.
Welcome.
And that's all, Prof.
Thank you, Luqman. Thank you all.
Prof. Okay, so now, if there's no more question, next I would like to invite Ms. Huda to begin her research progress presentation.
My topic is I'm PhD, Amyotrophic Lateral Sclerosis Progression Prediction Model based on deep learning. My main supervisor is Professor Dayang, and my co-supervisor is Dr. Norhayati. Okay, as a beginning, we would like to know some overview about what is ALS. As a shortcut, we will say ALS. So, as we said, we would like to know some information or some background about ALS. ALS is, as I said, a shortcut for amyotrophic lateral sclerosis. Is a disease that impacts the neuron system on adults, which is causing the motor deficits and weakness in lower and upper limbs muscles. And as a result, it's causing difficulties in moving arms and legs. Currently, unfortunately, there are no clear or certain tests to diagnose such a disease. So the only medical way to diagnose such a disease is by exclusion other similar disease with similar features. For the problem background, previous prognostic studies in ALS use traditional statistical approaches. In ALS fields, many researchers has been adopted, whether they are using statistical approaches, which are the traditional way, or the machine learning approaches. For the statistical approaches, we have many examples for approaches adopted, statistical approaches such as Cox regression and Kaplan-Meier estimators. But unfortunately, these methods have some limitations in the data. For example, the data assumptions are so strict, which limit the model validity and the data exploration. However, there are many advantages for using such approaches, and statistical approaches provided many contributions in terms of indicators, finding the indicators that are related or that can predict the ALS disease, such as diagnostic delay, age of starting the symptoms, and functional disabilities, and etc. So after the emergence of machine learning model, many models have been adopted in ALS field. The main approaches in machine learning, the main approaches in ALS using machine learning was divided into 2 parts: the supervised and unsupervised approach. And there are many algorithms adopted in ALS, such as random forest and support vector machine and KNN and so on. For the problem statements, we will discuss it from 2 perspectives: the domain problem and the technical problem. So, as we said, that ALS survival is a disease that affects the neuron system of adults, which causes difficulties in moving arms, and the survival ranges from 3 to 5 years. So, despite there are many tireless research efforts, drug development efforts are unsuccessful, and the clinical trials have many barriers, such as disease heterogeneity, late-stage involvement into trials, and mixing other patients with similar disease features. For the technical problems, although machine learning has provided many improvements in the field of ALS and outperformed the statistical models, they are limited in terms of data constraints, sensitivity, and specificity. So long trials are needed using machine learning, and huge data sets are required in machine learning models. In addition, overfitting is a common shortcoming in machine learning model, which will limit to generalize the proposed model. For motivation, after the emergence of deep learning has outperformed from previous studies and similar fields. We have found that deep learning outperformed machine learning in medical fields, and it extracts simple features from the input data using general purpose learning procedures. And we have found that there are many advantages of adopting deep learning algorithm over machine learning algorithms. For example, the deep learning algorithm or approach successfully constructs a high-level transform features from the input data, and these features are are robust, and error signals are reduced between the layers, because as we know that the main advantage or the main feature of deep learning is having many layers. And another advantage is maximizing the predictive accuracy of the model. For our research goal and objectives, the main goal of this study is to better predict ALS prognosis and produce an efficient clinical trials with shorter duration. And this goal can be achieved during based on many objectives. The first one is analyzing a PROACT database dataset. The PROACT dataset is the dataset that is adopted in our research. Number two, studying the most ALS predictive data features in the PROACT dataset, and proposing a feed-forward deep learning model to forecast the ALS progression or improvements. And finally, implementing and evaluating the proposed model accuracy. For the literature review, issues in ALS can be divided into three scopes according to the literature review that machine learning was trying to solve. The prognosis, which is the main focus of our study, and diagnosis and risk categorization. For prognosis, machine learning models were adapted to predict the progression of ALS, whether it is low, medium, or high prognosis. And the performance of such models depends on the feature's ability to predict the disease improvements and to predict the spread of the disease. Different types of and different datasets were used in such literature, such as the PROACT database, which is the main focus of, which is the main dataset that is used in our research, and other main real-life datasets. For diagnosis, we will just give a short information. For a diagnosis model, to construct a high-performance model, features should be describe the disease improvement. So a model is considered optimal if it is able to demonstrate early stages sensitivity and specificity that the patient can. So when we describe the disease improvement, the patients can be then enrolled faster in clinical trials area. Limitation of such studies can be summarized by limited data availability for training and poor samples to feature ratios. For the risk stratification or categorization, it has been studied from the prognosis perspective, and it's also focused on dividing the patients into some categories and giving each category a specific drugs. So this table represents the machine learning models in ALS prognosis. As we can say, some of these researches ranges from 2014 to 2018. The datasets adopted in this research were the PROACT database and real-life database. Dataset size ranges from 136 to 6,000 records according to the adopted model or method. For the data pre-processing, we can say that many data pre-processing techniques were used in the researches, such as the missing value removal, value importance analysis, feature selection, for example, and multi-value, for example, missing value imputation, and so on. Models used in ALS fields in machine learning are wide, such as Gaussian and random forest neural network. The most famous is random forest, of course, and so on. We can say for the performance assessments that the accuracy ranges from 56 to 84%. And we can say that in some researches, specificity and sensitivity were also mentioned according to the framework used, whether it's classification or regression. For example, here specification in the first paper was 74%, using random forest in the second paper was 66%, and so on. For our research framework, the first stage is starting by literature review and related work. A review of related work is going to be conducted, and the selection and studying of the datasets, which is going to be used in this study, which is the PROACT database. The second stage is the preparation of data and feature selection. Data pre-processing techniques are required to manage some noise and some missing values in the dataset. And in the second step, we need to identify and select the most predictive features to maximize the model accuracy. The third stage is developing and implementing the proposed model. The proposed model here is a feed-forward deep learning model. Result analysis and performance assessment. We will evaluate the ALS factor results using with our accuracy metric, and we will compare it with other previous works using whether neural networks or machine learning. For the documentation, we will study on the current practices, describe the purpose of the research, explain our research methodology, and report on literature. The proposed design model. The first step is by pre-processing the ALS data, or the PROACT data, as we can say that here, is going to be fed into the first step, which is the pre-processing step. Data pre-processing techniques are going to be adopted, as I said, to manage some noise and some over-existing of some features in the dataset. And in the second stage, we will identify the most predictive features, which maximize the performance and the accuracy of the proposed model. In the second step, a pre-training is adopted here. In this step, the model is going to be fed with all the features in the dataset to extract the most predictive features, and to come up with the optimal model with the optimal hidden layers. In the third step, training and testing, the dataset is going to be divided into 80 to 20% for training and for testing. And in the fourth step, performance comparison, we will evaluate our results with other and compare it with other previous works in ALS. Okay, that's it. Thank you so much for listening.
Okay, thank you, Ms. Huda, for the presentation. Okay, we are approaching the end of the colloquium for today. So if there's nothing else, thank you again, Prof. Dayang, for the sharing, and Ms. Huda for the presentation. And lastly, thank you everyone for your participation. And we'll see you again in the next colloquium. I think that is all. You can leave the meeting now. Assalamualaikum and have a good day.
Waalaikumsalam. Thank you very much, Lukman. Thank you very much, Huda. Assalamualaikum.